Hello and welcome everyone. This is Jimmy Boy, and many of you, my classmates, have asked how to solve an elasticity demand problem, so that's what we're going to do today, using the calculus method. So first of all, what is elasticity? So economists use this term to figure out the price. When there's a price increase, how will that affect demand? So we can describe elasticity as an inverse relationship, where if there's a price increase, usually demand decreases. Now we can separate this into inelastic and elastic demand. Inelastic is where the price increase will not significantly affect total revenue. And we can denote this with little ed for elasticity demand. And if ed is less than 1, our coefficient, then that is inelastic demand, meaning a price increase will not significantly affect total revenue. Now suppose we have our elasticity of demand greater than 1, then this is an elastic product, which means a price increase will significantly affect total revenue. Okay. So in order to solve for this problem here, let's read it first though. If the demand for a product is given by P equals 148 minus 2Q plus 1 cubed, find the point elasticity when the price is $20. What type of elasticity involved, and how will a price increase affect total revenue? Okay. So in order to solve for this problem, we are going to need to find dq dp, or the change in q in respect to p. Okay, and to do this, we're going to solve, differentiate implicitly. So usually when we differentiate equations, we do it explicitly. Differentiate equation. So instead of solving for dp dq, which is just regular differentiation, explicit differentiation, we're going to solve dq dp, which is differentiating the equation implicitly. So we're solving in terms of q instead of in terms of p. So here we're going to set up our equation to solve implicitly. We have the derivative of p, the change in p with respect to p, equals the derivative of q, which in this case, or p, 148 minus 2q plus 1 cubed with respect to p. Okay, that's what we have so far. Okay, and so we learned back in calculus that the derivative of a constant is always 1, so the derivative of p is just 1. Okay, 1 equals, and then we're going to differentiate the q function here. So anytime we have a constant, the derivative is just 0. So back here we had p, the derivative of, I guess that wouldn't be a constant, that would be a letter, is 1. That means a constant, the derivative of this constant would be 0. So we just omit that. Then what we have left is negative 2. And then part of the chain rule is we bring down the exponent down. So negative 2 times 3 times the inside function q plus 1. And usually to finish off the chain rule, we would differentiate the inside function q plus 1. In this case, the derivative of q plus 1 is just 1, because the derivative of q is just 1. If you don't know how to differentiate inside functions, I can definitely post up another video on how to do basic differentiation, but by now you should know how to differentiate this. Okay, so instead of multiplying the inside derivative of the function, we're going to go ahead and leave it in terms of dq dp, which technically that's what it is, right? When you find the derivative of the inside function is the change in q with respect to p. But instead of actually solving for that, which is 1, we're just going to leave it as dq dp. Okay, so this is what you have so far. 1 equals negative 2 times 3 q plus 1 times dq dp. Okay, and let's go ahead and simplify. So we have 1 equals, what's that, negative 2 times 3, negative 6. We got q plus 1. Oh, and also this should be a squared. So when you bring down the power, you have to subtract the power minus 1. So instead of, before it was cubed, q plus 1 cubed, now it's q plus 1 squared. So this would be 6, negative 6, q plus 1 squared. And we have dq dp. Alright, so the only thing we have to do in order to solve for dq dp now is to get it alone. Right now it's attached to this negative 6q plus 1 squared, so what we can do is just divide negative 6q plus 1 squared or multiply by the reciprocal. So let's go ahead and divide this out to both sides. Negative 6q plus 1 squared. And then we get dq dp equals 1, I guess negative 1, over 6q plus 1 squared. Alright, so this is probably half the battle, because in order, our demand equation is actually this little guy here. So we have ED, elasticity demand. In order to find that, is going to equal negative price over quantity times dq dp. Okay, so let's see what we have so far. We're given that price is actually $20, so we can actually put that in there. For P, negative 20, and the reason why that's negative is that so when we finally get our elasticity demand, it's going to be a positive number rather than a negative number. So it's only there just to make it positive. Okay, we don't know what Q is yet. We're going to multiply this by dq dp, which is negative 1 over 6. Again, we don't know what Q is. So at this point, we're going to have to solve for Q before we go any further. So to solve for quantity, let's go ahead and refer back to our price equation, or our demand equation, which is P equals 148 minus 2q plus 1 cubed. And this is our demand equation. Alright, so we're going to solve for Q. Let's plug in 20 for price, since we know that, because in order to solve for one variable, we had to isolate it. So we have 20 equals 148 minus 2 q plus 1 cubed. Alright, so let's go ahead and solve for Q. We're going to subtract 148 first. Makes it easier, and when we do that, let's see, what's that? Negative 128, mental math, equals negative 2q plus 1 cubed. Divide negative 2, that'll make that a positive 64 equals q plus 1 cubed. And let's see, 64, and then to get out of a cubed exponent, let's go ahead and take the cube root or multiply by a third exponent. So that would be, let's see, what is that? It's 4. Alright, so 4 equals q plus 1. Go ahead and subtract 1. So we find out that quantity actually equals 3. Perfect. So now we can finally finish up our equation here. So let's see, elasticity demand is negative P over Q. Well, we found out quantity equals 3. Put that in there. And finish out with Q, 6, let's see, negative 1 over 6, 3 plus 1 squared. Okay. So we are now going to solve for the elasticity of demand evaluated at quantity equals 3. So once you can actually put this all into your calculator at once. So let's see what we get here. Negative 20 divided by 3. Well, if you break it down, you can actually just do negative 20 divided by 3 is negative 6.67 or 666 repeating. We'll just keep it rounded up to 6.67. And we multiply, let's see, negative 1 over, let's see, 6, 3 plus 1 squared, 1 divided by that. And we get negative 0.010, which then reduces down to let's see here, 0.069. Okay, and that is less than 1. So this would be referred to as inelastic demand for this product. Inelastic demand, which means that a price increase will not, circle my answer, will not significantly affect total revenue. Okay. A good example of an inelastic product today would probably be gas. No matter how much it increases, which is ridiculous. Well, now it's actually not too bad. It's like 2.45 cents per gallon for regular. But yeah, that gas would be inelastic because no matter the price increase, everyone always needs gas. So the demand isn't really going to change that much. Now, suppose we have something like Coke, for example. If the price increases for Coke, well, people see that as a substitute good. So they'll go ahead and jump right over to the Pepsi bandwagon and start drinking Pepsi until the price of Coke goes down again. And then all the Coke fans will go back to drinking Coke. Or maybe if they're loyal, they'll stay with Coke. Who knows? But yes, this was how to find elasticity of demand. Business and economics application for calculus. Business for calc. Calc for business. If you have any other questions, feel free to leave a link, or no, leave a comment down below in the comment section, and I will review it and give it consideration. Thank you so much, and goodbye.